Hey guys, welcome back to another video. Today I've got a DLP rear projection TV to take apart. This one is 61 inches and it was the biggest and most expensive model available. DLP projection TVs are a newer and more expensive type of projection TVs that came out after CRT projection TVs, but before LCD TVs. An image is projected from the back side of the TV onto the transparent screen. It's just the picture is generated by a DLP chip and a halogen light bulb, and not 3 CRTs. Just like the other projection TV, you can see the front screen is floppy. That is because it's basically just a transparent screen. On the side here we have some basic control buttons. We have volume, channel, menu, and source. Here we have some AV inputs here. Here's our information sticker here. This TV was made in September of 2005. You can see it is model HL-R61. This is the 1080p variation. The slightly cheaper one is only 720p. Here's our audio video input panel. We have lots of component video inputs here. We have a AnyNet connector, which is a HDMI control interface. We have a RS-232C connector. We have our optical audio out. We have some HDMI PC input. We have a special USB debug port here for servicing. These two connectors are Thunderbolt connectors. We have a G-Link connector here, which is for high quality audio and video input. Here's our old-fashioned antenna inputs. And below here is where you would put your cable card. The next thing I'm going to do is take off this front screen assembly. Now we need to remove this cable here that's going to these buttons. We have a few snaps here holding it on. Here's the remove button assembly. We're going to have a few buttons on the other side of this board, and that's pretty much all there is to it. Alright, to remove the lenses on this panel here, we're going to have to remove this black bezel here. Okay, the screws have been taken off, and you can see the lens assembly here underneath this bezel. Okay, so on this TV we have two lenses. Here we have our Fresnel lens. This second lens is a diffusing panel. Right here we have a large optical grade mirror. Here's the projection lens where the final image is projected outward onto this mirror. From there it reflects off the mirror into the transparent screen. This aluminum piece here is holding on the mirror. It is interesting that it looks like it has fins like a heatsink. This could either be because it is used to dissipate heat in some way, or it's just part of how it was manufactured. Alright, so the next step is to take off this whole top assembly from the bottom assembly. In order to do this, we have to take off all the screws on this bracket. We also have to take off all these screws here in the middle, and the screws on that bracket too. We also have screws to remove underneath this back panel here, so let's remove that. First I'm going to take off this cover here, which covers up the bulb. Here's the cover. Here we have a big air duct here. It has lots of guide vanes for guiding the airflow. As you can imagine, this halogen bulb creates a ton of heat, so there is quite a substantial cooling system to cool it, and all the hot air would be exhausted out through this panel here. To take this cover off, we have to take off all these screws around it. So let's get those screws taken off and we can take off the top assembly. Alright, so here's what it looks like removed. This is a very big plastic piece. Here's the bottom assembly. This is what's going to be interesting. Alright, next I want to take a look at these speakers. I have discovered that if I remove the two screws underneath on each side, I can actually pull this cover off just like this. Here in the middle of the grill we have a small circuit board which is used for the button and infrared receiver for the remote control. Here's the other side of that board. We see the infrared receiver of a few LEDs and transistors. We also have a button here. Here's a closer look at the speakers. You can see This one here is a little bit damaged, so I'm not the first one to have been in here. Looks like we have two woofers, or possibly mid-ranges, and we have a tweeter. Alright, the next step is to remove this long plastic piece here. We have 8 screws here in the middle holding it on. We pull it up. Here is our 3-inch speaker. You can see these have a neodymium magnet. Over here is the tweeter. We do have a capacitor wired onto it, so it plays only high frequencies. Here's the cavity that they were mounted in. You can see we have some foam in there. Here we have the wiring and the circuit board for the audio-video inputs on the side of the TV. Next, I'm going to take out the power supply module, which is this piece right here. You can see it's right by the power connector. So these two wire bundles are the low voltage output from the power supply that supplies low voltage power to the other assemblies in this TV. Here's a closer look at the board. It's a pretty nice board. We have 2 giant capacitors there, some inductors. You can see they have the 2 sections of the power supply labeled as the hot section and the cold section. The hot side of the power supply is going to be the side that receives the 120 volts from the outlet, and the cold side is going to be the output side with all the low voltage outputs. Here's the back of it. You can see we do have some spark gaps here, some small ones here underneath those inductors. You can see that they've added solder to the high current traces. That's because these traces are carrying high current. You can see the only thing connecting the hot and cold side are these transformers and the opto isolators down there. These transformers serve the purpose of stepping down the voltage. They are the main voltage reducer on these power supplies. Okay, so the next thing to look at is the video processing boards. First, we're going to remove this plastic piece here. And we can also slide this module out. Okay, now we have to undo this wiring to get this module out. We have some ground wires here. Here is a cable that goes to this other board over here. We have our 2 harnesses coming from the power supply. Here is our speaker connections. Our last connector to remove is this DVI connector, which goes to the DLP driver board. And it's just pretty much a regular DVI connector. Alright, here's our video processing module. It's all built into this one assembly here. First, I want to remove this center board, which I believe is responsible for input switching and the general peripherals on the TV. Alright, here's the board. Here's our input connections. Here's the back side. We don't have much on the back. Looks like we have a section here for power regulation. These 2 chips here are the audio amplifiers, and here is the connector going to the speakers. We have 2 MOSFETs on these small heat sinks here. These are either for power supply functions, or they're also being used along with these audio amplifier chips for driving the speakers. Here we have some sort of ROM chip, so this chip must contain data for operating the systems on this board. These 3 chips here are video cellular matrix chips. They are responsible for switching between the analog video inputs. This chip here is a 3-dimensional YC separation chip. Basically, this chip is responsible for decoding audio and video from the S-video inputs. This chip is a bus-controlled audio matrix chip. It is responsible for switching between audio inputs. And this chip here is a sound processing chip. That's about it for this board, so let's take a look at the other stuff. Okay, so I have discovered that this top metal piece just slides off once I've taken out the screws. On the back side you can see the small 12-volt fan. Okay, now this board assembly can just be lifted off this other piece of sheet metal. And here is the shielded board assembly. Okay, so here's the board. We have a very nice board with a lot of chips on it. This board is responsible for taking in all the different video sources and processing and enhancing the video data before it goes to the DLP board. We need multiple video processors because this TV is able to use so many different video sources. This chip is the Samsung DNIE, which stands for Digital Natural Image Engine. This custom chip has four main functions. It's got a motion optimizer that eliminates noise from video. It's got a contrast enhancer and a detail enhancer that sharpens the picture. It's also got a color enhancer. This chip uses two 64 megabyte SD-RAM chips that's used by this DNIE chip while processing image data. The first one is here, and the second one is right here. Next, we have these two SoCs here. These are going to be doing the decoding and construction of the video from the different input sources. After that, it's sent to the DNIE engine for enhancements before being projected on the screen. Here we have the Genesis display controller. It is capable of decoding analog RGB, RF from the antenna, and other input sources. It has many other features and enhancements that can also be used. It outputs LVDS video data, which is an internal high-speed video data protocol that's used by displays and screens. Above the Genesis chip, we have a 128 megabit DDR FDRAM chip. This is used by the Genesis controller for storing data while it's being processed. The instruction data that this chip needs to function is stored on this 32 megabit flash chip. When the TV was made, it was programmed with all the code the chip needs to function. The second SoC is this ATI Zillion chip. This is a powerful SoC that is capable of all kinds of video processing. It can decompress multiple streams of video data at once. In this TV, it decodes composite video and S-video. When there is a cable card installed, it communicates with it to decode and unencrypt all the cable TV channels and construct audio and video for each channel. These two memory chips here used by the ATI chip are 256 megabit GDDR SD-RAM that is used while it's processing image data. These other two memory chips here used by the ATI chip are 512 megabytes each. They are DDR SD-RAM that is used for storing image data. For storing instructions, it has these two 256 megabit flash storage chips. Alright, so here's this DVI connector. This is where the final video output leaves this board and goes to the DLP board. So right behind it we have a DVI encoder chip. This chip is responsible for encoding the processed video data. Here we have these two HDMI connectors here. So right behind it we have a HDMI decoder chip. This chip is responsible for decoding the incoming HDMI, and it converts it into video data that is usable by the other video processors on this board. So these connectors here are the analog video coming in from the analog input board. So we have two chips here to convert that analog video into digital video. That is the responsibility of these two analog devices chips here. These chips are responsible for converting analog composite and S-video coming from the video input board and converts it into a digital video, which is usable by the processors on this board. This chip here is a Climax SP2 open cable interface controller. This controller is responsible for interfacing between the cable card and the ATI chip. It doesn't do any signal decoding, it's just strictly for interfacing between the cable card and the ATI chip. It's basically allowing the cable card and the ATI chip to communicate. Here we have those two FireWire connectors. So right behind it we have a FireWire controller. This chip here is responsible for encoding and decoding data using the IEEE 1394 protocol. Here's the back of the board. We have a whole bunch of surface mount components and a lot of these small little ICs. The most interesting one, however, is this super long one over here. This chip is a 32-bit bus switch network. Now let's take a look at these tuners. As we saw earlier, this TV is capable of taking in a cable TV input and a old-fashioned analog antenna input. Since these two connectors here are interchangeable, we need a way of separating the different incoming video types. So when we have a cable card installed here and a cable TV connection installed onto one of these connectors here, the relays will switch it over so that video data will go to this module here. This module here has the components necessary for taking in the cable TV data. You can see we have a ATI chip back here, and it is responsible for interfacing the cable TV input with this ATI SoC here. So when there's an antenna connected, the relays will switch the input over to this wire here, going over to this old-fashioned cable tuner box here. Okay, so the next section to come out is the projection section. Okay, so here's the assembly. First, I want to take a look at this circuit board right here. Okay, so these two connectors and wires go to the two fans on this assembly. We have some wires going to the DLP driver board, which is under this case here. And this wire here goes to the audio video input board. You can see we have some nice power management stuff. We have a power regulator and a MOSFET here. This chip right here is a remote 8-bit I/O expander chip. Next, I'm going to take off some of this plastic paneling here. Okay, so here's that divider piece. You can see here that it is labeled the lamp cover. So here you can see it says PC. That is the kind of plastic. This is polycarbonate. And plus G/F, that means it's glass fiber reinforced. And it has a 20% makeup of glass fiber. On the top here we have a thermal sensor to make sure it doesn't get too hot. Next, I'm going to take off this little cover here. This piece of plastic here has foam padding on it to help absorb the sound of the color wheel, which is beneath it. Okay, so here's the duct piece. You can see we have a nice fan here. So this piece redirects the air into the bulb, which was mounted in here. And we also have this small little offshoot duct here, which supplies air to this heatsink structure here. Let's take a look at this board. This board is the high voltage board for driving the bulb. We have a few wires coming off this board here, going up to the DLP driver board. So here's the board. This is basically just a high voltage power supply. You can see we have a high voltage transformer here with really fine windings. And you can see the two wires here are connected to this potted module here. This is either some sort of ballast or it's another transformer. You can see here we have what looks like a really large ceramic diode. Here's where the concentrated light from the bulb enters the optical assembly. Next, I'm going to take off this cast aluminum piece. Alright, so underneath this finned piece that I mentioned earlier is the color wheel. The color wheel has a motor and a glass disc which colorizes the light coming from the bulb. Once I've taken out the screws, I can pull it up like this, and you can see we have a large plastic gasket here to keep dust out. We have two wires here going to it. One of these is for the motor and the other one is for the sensor. We have a small 3-phase motor here that drives it. It's a pretty high RPM motor. We also have a small sensor here which detects what color the color wheel is showing at the moment, so it can be exactly coordinated with the movement of the DMD micromirrors. The glass pieces are actually colored cyan, pink, and yellow. Remember, the three primary colors of light are red, green, and blue. This is because the color wheel subtracts away the cyan, pink, and yellow from white light, creating red, green, and blue. To demonstrate that, I can actually shine my phone flashlight through it. You can see the red, green, and blue coming through. And then it would spin really fast, thousands of RPMs. I'm not sure why it has this one little slide of dark green. That is for some sort of correction to adjust the colors. You can see we do have this little fan here for cooling. It is mounted on these little rubber pieces to absorb vibration. Here's the fan. It's just a small DC brushless fan. To remove the DLP board, we have to take out these screws. Okay, so here it is. Here's the actual DMD, which stands for Digital Micromirror Device. This is what it would look like if you were to play video on the DMD chip. Basically, it would just be a grayscale picture. The next thing to do is to remove this heatsink bracket. It's just like a CPU clip. You can see here on the back of the heatsink the little protruding piece that makes contact with the back side of it. Alright, so here's the inside. We have 3 big VGA chips underneath these heat sinks. Okay, so here's the removed board. We still have this big mounting assembly here. Here's the top of the DMD chip. And there's the die, which has the array of micro mirrors. For every pixel on that screen, there's going to be a tiny little micro mirror on this chip that can be individually controlled. The resolution of this TV was 1920 by 1080, so that means that there's going to be over 2 million tiny little micro mirrors just on that die. And each one of those is going to be about 5 microns in size, which is incredibly small for a tiny little moving part. Okay, now that we have taken out those screws, we can take off this back piece here. If we flip it around here, we can take this out. We have this small plastic piece here which has these little tiny spring contact interconnects. You can see we have contacts here and contacts on the back of the DMD chip. And these tiny little springs make contact to both of them. Okay, now we can take it out from this piece here. And here it is, the piece that makes this whole thing possible, the DMD chip. As you can see, it's a very nice looking chip with gold and ceramic. Okay, so I've done some research about the chips on this DLP board here. Since the video data is coming into this board through this DVI connector, it needs to be decoded. So that is what this silicon image chip does. That is the DVI decoder chip. From there, the video data is sent to the XHD4 controller. So this board here contains 2 DLP chipsets. Each one of them is capable of driving a 720p display, but this TV is a 1080p display, and a 1080p display has twice as many pixels as a 720p display. So they're using 2 chipsets to get that high resolution. So this is the DLP controller. This chip is responsible for image processing and control. It formats the image data into the proper interface that the DMD chip uses. So this chip here is a configuration PROM. This chip is programmed with the firmware to properly configure the chipset. Also, each DLP controller has a flash chip. This is a 8 megabit flash chip for storing the algorithms and the instructions that this chip needs to function. This chip here takes in video data and does processing and deinterlacing before sending the data out to the dual DLP chipsets. This chip does have its own SD-RAM. It's on the back here. We have 2 64 megabyte SD-RAM chips. This chip right here is the power and reset driver chip. This chip provides the voltage generation and reset functions that the DMD chip needs to function. Alright, so now back to the lens assembly. I'm going to take this cover off here. This is just a dust cover. Now we have a little bit easier access to things. So it looks like this cover here can be taken off, so I'm going to remove that. Okay, so we have this tube lens assembly here, which the light is going into, and that mirror is going to bounce the incoming light onto the DMD chip at a slight angle. Okay, so once we have the incoming light on the DMD chip, each micro mirror is going to either be tilting towards that light to create a bright pixel, or it's going to tilt away from the light source to create a darker pixel. Since the micro mirrors are mirrors, they are going to be bouncing the light back into this lens here and out our main projection lens. Since the micro mirrors can only be on or off, meaning they can be tilted to the light or not. They cannot produce shades in between full brightness and no brightness. To get around this, the DMD controller chips use pulse width modulation to move the micro mirrors between the on and off positions extremely fast. Depending on how long the mirror is in each position, the exact shade can be made. For every single frame of video, the color wheel will rotate enough to have 2 cycles of red, green, and blue light through. While the red is showing, the micro mirrors will adjust to create all the different shades of red in that exact frame. It will be the exact image, just in red. Then the same thing happens for the green and blue. So in every frame there will be 6 quick flashes in the frame in the order of red, green, blue, red, green, blue. This happens so fast that your eyes perceive the complete frame as a full color picture. So every second, 60 frames will be processed and displayed every second, and then we perceive that is video. You can see here we have some sort of adjustment. Next I want to take off this little lens assembly here with these screws. Okay, so here's that lens assembly. So here's where the incoming light goes, and here's where the exiting light comes out of. You can see we have a very strange optical pattern inside there. Basically this lens assembly here is taking the light and getting it ready to be pointed onto the DMD chip. Not sure why it has that pattern, but the light's going to come in super concentrated, and it's not going to be so concentrated once it comes out this big lens here. You can also see here we have tiny little adjustment screws, and this is what it looks like when I put it on my camera lens. It's all fractally. Okay, the next lens assembly is this one here. It comes off with these 6 screws. So the picture is going to go through this lens here. There's some sort of mirror back here, and it's going to be reflected out onto the screen. You can see we have a plastic piece here to keep it the correct aspect ratio. Alright, next I'm going to take off this main lens here. Here's the lens. Okay, so I've removed this piece, and you can see this lens is a very strange shape. You can see it's like a normal lens, but then it's going inward. So here it is on my camera. You can see this lens greatly expands the field of view. I believe that is because this lens is a fisheye lens. You can see that only the one side here is open. That's because of the way that the light is reflected off the DMD. So it only comes in on this one side. On the back of here we have this little electronic piece here that says dynamic black. It turns out this is actually a small actuator, and that actuates this metal piece here. So one of the features of this TV is a dynamic black. So in a particularly dark scene in a movie or TV show, this actuator here would close this little piece which restricts light. So you would get a darker picture on the screen. This actuator here might actually be variable, so you can cut out different amounts of light. This wire here connected to that I/O board. Alright, so here's the actuator. We have this small anodized aluminum piece. On the back here we have a little circuit board. It's kind of hard to see, but we have a transistor and a small IC chip on it. Alright, so let's take a look at this. We have this mirror in here, and we have some electronics on the back side for it for some reason. Okay, so here it is. If I take out this little mirror and the metal piece it's on, you can see that we have some coils of wire and some magnets. So this mirror would be able to move a tiny little bit just to adjust the picture just slightly using these electromagnetic coils and the magnets. Alright guys, that's about it for this video. I hope you guys learned something, and thanks for watching.